intelligence into your AI solutions. Hopefully that's the only slide I read for you word for word, but I figured it was wordy enough that I wasn't going to get it right unless I did. So yeah, hopefully you're here for that talk. What we're going to do today, though, is, I guess before I tell you anything, I have to tell you this, which is that anything I say that is forward-looking, you should take with a small grain of salt. And just, don't trade stock on it and don't hold me accountable to it a year from now, because the future is moving quickly right now. What we're going to do today, we're going to spend a little bit of time diving into the Mosaic AI platform overall. We're going to start with really diving into a deep dive on agent bricks and kind of going through the bricks and what they're about and how they work. And then we'll actually do a demo of the bricks, of most of the bricks as well. Then we'll move into changes to the AI platform and some of the new capabilities of our AI platform that are not bricks. And so we'll go through both of those, and then we'll do a demo of kind of that overall capability for someone who wants to kind of manage this more at the DIY level than at the set it and forget it level, if you will, right? So that's kind of what we're going to do today, and assuming we do all this well and we do this relatively quickly, we will have time for questions at the end. So as you're going through, hold your questions, and we will do our best to answer as many of them as we can. Tech folks, can we get the timer running? Thank you. All right, so let's dive in. So first of all, apologies in advance. When somebody calls your baby beautiful, you force everyone in the world to take a look at your baby, and so you are forced to look at the Gartner Magic Quadrant, where they recently named us not just a leader, but really the leader on both dimensions. And to be honest, last year we were also in the leader group, but we were the highest up on the ability to execute, but we didn't have the strongest vision of all the groups. There were some groups that beat us on vision, but this year what we shared with them is we shared with them some of our thoughts on evaluation, and we shared with them some of the early prototypes of our bricks capabilities. And really, I think it was what we're doing with bricks and the difference between that product and a lot of what you see at the hyperscalers or at the competitors that really differentiated us on that dimension. And so we'll dive into some of that, and you can learn a little bit more about that. But let's start here, right? As we look at the world today, and folks, everyone wants to build AI, but what we see is that the vast majority of AI that gets built never really makes it beyond the builders, if you will, or maybe the builders and their friends or something like that. Rarely are these systems actually making it to production. And when they make it to production, even then, oftentimes production is, myself and my org or something like that. But really building these systems such that you can start putting them in the critical path of risk, either of kind of, externally facing customer, reputational risk, or internally facing maybe financial risk, right? That's really where I think a lot of folks imagine they want to be able to deploy this technology, but that's still out of reach of many, right? And so, you've heard a lot so far this week about this idea of data intelligence. I was recently at the Anthropic conference where they announced Claude 4, and the head of product for Anthropic got up and said, the first thing you need is a great model, and the second thing you need is to bring your data to that model. And that's really our goal, is we want to help be the ones who do a great job of helping you bring your data to the model and really optimize that system. Now, why is it that 90% of these systems aren't getting there? I think it's a few reasons. The first is evaluation. Not only is evaluation difficult, but for many, evaluation is simply out of reach, right? Or to do evaluation at any reasonable scale is simply out of reach, right? If we were to have had this conversation last summer, we would have talked about vibe checking. Now we talk about vibe coding, but last summer it would have been like, you built an agent? Like, did you vibe check it? And vibe checking, usually what that means is, did you test the questions you set it up to answer? Yes? Great. But how do you ensure that it actually works beyond just that set of questions? How do you ensure that it's going to consistently give you the results you need, right? 85% of users rely only on this manual checking, right? Which really is scary if you think about starting to deploy these systems into either those financial or reputational risk use cases. Now, the second piece of this, I should say, is too many knobs. And right, when we say too many knobs, what do we really mean? Well, there's a whole bunch of models that you can choose from, but there's also a whole series of components that you can use, right? Hey, are you gonna use a vector DB? If so, how are you gonna operate that vector DB? What are you gonna use for, what's the search technique you're gonna use? What other components are you gonna use? Are you gonna be calling, structured data and all these kinds of things? And, we think of these as straightforward, relatively transactional relationships, but there's actually, for those who have kind of some machine learning background, there's tons of hyperparameters that are dying to be tuned in these systems to really make them perform at kind of state-of-the-art quality, right? And then the lastly is this idea of trading off cost versus quality, right? A lot of folks we see, they start with, Claude 4 or Gemini or GPT-4, GPT-4o or GPT-4.5 or something like that. And what they find is they build it at that bar, but they have a hard time kind of exploring that frontier of cost and quality, right? We don't actually need the best answer, the best possible answer for all use cases. And sometimes, depending on the task or the question we're asking the system to do, we can get just as good an answer from a smaller, much less expensive model, and we don't need the overkill of that large model. So really kind of trying to figure out how we balance all these three has been something that we've continually seen customers struggle with. Now, with that, we obviously brought out Agentbricks, announced yesterday. Agentbricks is really designed to help you build and optimize these agents. Now, I want to take a quick moment and stop and say, we know that it took us longer to get to a no-code solution than a lot of our competitors. And that wasn't a mistake, right? For about a year, I've been getting beat up by customers and by our sales team saying, hey, why don't we have one-click RAG like so-and-so has? Why isn't it just that easy? This technology, because this technology is so accessible, we all imagine, or at least our CEOs and what have you imagine, that it should be that easy to program, that it should be that easy to bend to what I need it to do. But what we know is it's actually quite difficult to get these systems to consistently give the results we want. And so we were unwilling to build a no-code system that was a toy, that gave you only kind of, one-click quality results. And so it wasn't until we had our evaluation platform up and running and we were confident in that evaluation platform that we could really change the dynamic of how these systems are created. Instead of these systems really optimizing purely for simplicity, our goal is to bring the user into a kind of iterative quality discussion, right? If we can pull the user in and say, hey, help us understand what good responses look like, then if we can do that enough times, we can start to ensure that the system is tuned to their liking. And that's really what we're going after with Bricks, right? Is how do we kind of take all of these different methods of deployment or methods of building these systems and kind of optimize them all in an attempt to maximize the quality of the system you're building. Now, with that, Agentbricks has automatic evaluations, right? At every step, we're sitting there trying to figure out how to make it work better. It optimizes on your data and your tasks, and it gives you the ability to trade off that cost versus quality, right? So that you can figure out where exactly you need to be on that frontier. Now today, or yesterday I should say, we launched 4 bricks. This is just the beginning. There will be many more bricks in the fullness of time. Well, there's actually an argument on the team whether or not there will be many bricks or 1 brick, but the goal is, certainly to be able to reach more and more use cases over time. Today, these are the ones we're launching with, right? Information extraction, the ability to take your corpus of texts and pull information out. Knowledge Assistant, which is basically a RAG, a highly optimized system for driving RAG accuracy. Custom LLM agent, which is really our kind of custom task. Hey, you have a task you want these systems to do. Great, we'll help you ensure that the system is doing that task successfully. And then multi-agent supervisor for stringing these systems together in intelligent ways. So let's dive into each of these with one more kind of layer of depth. So starting with information extraction, this is great for those companies who have contracts. I was talking to a telecom recently, and they said we have tens of thousands, maybe even hundreds of thousands of contracts with the folks who have built our network. And the problem is there's all kinds of custom terms in those contracts, and they said we're leaving a lot of money on the table because we don't know all the times that we could go back to those vendors and say, hey, you didn't meet this one term of the contract we had with you. And so what they need is they need the ability to look at that information kind of systematically and compare it. But when it's caught in a filing cabinet or it's caught in a repository of PDFs, they just can't do that the way they want to. So how does this all work? Well, you provide a series of documents, and you define the JSON scheme for what you want extracted from those documents. We then iterate on quality, showing you examples, trying to understand whether or not the examples we're pulling out are good. You give us feedback. We then use that feedback to drive improvements in the model. You can then choose how you want to optimize on the cost versus quality metric, and then you can take that kind of final system where you're proud of the quality and deploy it against your tens of thousands or hundreds of thousands of documents in that case. Now, we also, as I said, have custom LLM agent, or this task-specific system designed to help you kind of go and build a system for a very specific task. Maybe this is you want to summarize your customer calls. Maybe this is you want to generate reports, maybe analyze sentiment. I was talking to our PR team yesterday, and they've had the challenge of the fact that all the executives at Databricks have been doing PR and getting interviewed and all this week, and they've had to print out like tons and tons and tons of prep docs for all these engagements. What if building those prep docs was just a task that the agent did, right? And again, engaging with quality in this system to really try and drive that system to perform in a way that you could say, hey, I want to make this a set it and forget it capability for myself moving forward, right? So how does it work? We basically, give it the kind of what we're trying to do and define that criteria, right? And then we'll start generating what we call guidelines, which is really feedback on how you want this graded. Hey, these types of responses are unhelpful. Hey, this tone should be improved, right? Give us that feedback, and that feedback doesn't need to be real precise. It can kind of just be natural language feedback around what you want to see more of and what you want to see less of. We then take that, we continually optimize the system, right? And not only are we using that feedback to optimize the system, but we're also using that feedback to help train judges to start duplicating your feedback to us. Because if we can train a judge to duplicate your feedback to us, then we can synthetically go optimize the system, and the next time we come back to you with some examples, they'll actually be far better than they had been previously, because we've had the ability to get that feedback offline while we continue to optimize the system. Now we move from there to knowledge assistant, right? Or our kind of RAG, compete system, if you will. And this is really, I think we all probably understand RAG. I have a massive corpus of text that I want to have a chatbot on top of, or something along those lines. And in this case, again, maybe you have technical docs, maybe you have product support knowledge, maybe you have, financial or contract information, and you want to just be able to have that kind of classic chat experience on top of this, but you want to ensure it's a really high quality outputs that we're getting. So what do? Pretty straightforward. Specify the name and description. And by the way, when you specify that name and description, don't just say foo and bar, because what we're doing is we're using every piece of information you give us. That description and that name, that's part of us tuning the system to help have it perform better. So the more verbose or the more clear you can be about what you're trying to do, more likely the better we can tune and the more quickly we can tune the system to do what you need it to do, right? Then you connect us to your volume of text documents or PDFs or what have you. You connect us to your vector store or your embeddings, right? And from there, we start optimizing. And we start giving you, We'd start taking your questions, getting feedback, synthetically generating questions, getting feedback, until we can really get to a place where we can answer these things just like you would want them answered. And finally, multi-agent supervisor. Multi-agent supervisor really came to us from our customers, because time and again our customers would say, hey, I want a RAG system, but I want that RAG system to be able to run queries. Right? I want it to be able to return both structured and unstructured data. Right? And so what have we done? We've built this multi-agent supervisor that lets you really easily build an agent that is really a series of other tools or agents beneath it, right? And in that environment, in that multi-agent kind of system, we're able to help you drive accuracy not just on a single agent, but across that entire continuum of agents that are built. Right? So that's really where we're starting off with Bricks. These products are still in beta, and we're still kind of trying to drive the optimization to the highest quality we can, and trying to kind of work out some of the hidden gotchas, if you will. But it's extraordinarily exciting to see some of the things that have been built already. So by the way, the multi-agent supervisor, as I said, again, specify the name and description, add those agents or those tools, and then again, we're going to go off and optimize and start giving you examples to give us feedback on until we get to a place where your feedback is consistently really strong. So these systems, we compared these systems to some of our cloud competitive, easy, kind of, one click, or, the best way, the easiest way to go build these systems on clouds. And, these are blue clouds and rainbow clouds that we're comparing them to. And, you can see here that we were able to beat them pretty much right out of the box. Now, this is how we beat them at zero shot, just when you give us the information. The really cool thing is that as you continue to give us feedback and guidance, we're able to drive the accuracy even higher, right? So as you see here, the Joel from Hawaiian Electric talks about just how significantly they were able to drive improvements to their LLM-based systems using these capabilities. So, when we think about how all of this works, if you kind of think about this on a quality dimension versus a complexity dimension, right? The really easy low-quality ones are what we've consistently seen as no-code builders in the past, the one-click RAG capability, right? And then there's the high-quality ones that are relatively complex, where organizations have spent, weeks or months kind of tuning their systems to better work and experimenting with different methods and techniques. Our goal is really to make it easy and high quality, right? A real leapfrog moment for the industry, where instead of focusing just on simplicity, we get there by focusing on the simplicity of evaluation, right? And now, how are we able to do all this? Well, we are able to do all this really by taking advantage of, back in the traditional machine learning days, we would have a model, the model would have an output, we'd get a score, and then we would go and say, hey, we want that score to be better. I'm going to go get other data. I'm going to go get other features. I'm going to keep tuning and experimenting on this model to drive accuracy. We wanted to create that same accuracy hill climb challenge so that you could invest your time or your team's time in helping really drive it to the level that you need it. Now, what we've done differently here is you get that output, you get that score, but instead of going and looking for better features or tuning the hyperparameters, you just give us guidance. And by guidance, I mean you give us natural language feedback as to how you think this could be improved. Now, the challenge with guidance is that it's hard, right? Guidance is super ambiguous. Humans don't tend to speak in super specific terms, right? Hey, can you just improve the tone of this system or something like that, right? Or, and guidance is often specific. Hey, this answer is wrong, right? Or guidance is maybe, there are so many components that guidance doesn't make it real clear of, to get this response back, do I need to make changes to the prompt or to the vector DB or to the search method of the vector DB or to how I'm involving the internet search in this, or, and there's lots of different levers and knobs, again, that keep it from being real easy to just implement that guidance. And so what we've been working on here is really this kind of feedback system where if you give us some information, hey, ignore data from before May of 2020, we could think to ourselves, well, I guess I'll just go and remove those from the vector index and we're good. But really what happens is we need to go take that guidance, and we need to go and adjust multiple components of the system in order to optimize that accuracy. And that's really what the bricks are doing underneath all of this. So with that, I am going to ask Amber to join me on stage and show a demo of building out some of these bricks.
Testing, testing. All right. Full screen. Everyone in the back, you can see the screen well? All right, thumbs up. Great. All right. Hi, everyone. I'm Amber. I'm going to be walking you through 3 bricks today. So these are going to be information extraction, custom LLM, and knowledge assistant. You saw the multi-agent demo that Casey did at the keynote. This is going to be a deep dive into 3 other bricks that are available in beta. And going through these, this is a deep dive session. I don't want to just show you how you can build on Databricks. I really want to show you why it was built this way on Databricks in the first place, where we're looking ahead. And like I said, this is cutting edge. So if you see like modified an hour ago, it's the latest tech. So let's kind of dive in. First, we're going to set up our scenario. So let's say we are a company called Client Care. We are like a superstore. We sell a lot of products, and Client Care, much like a lot of our customers, is more interested right now in kind of deploying agents for internal use cases to help with productivity, help with enablement. Still interested in what they can do with chatbot capabilities, but not having to have the same levels of productionalization, same levels of governance for kind of communicating directly with customers. We're just seeing a huge increase in internal use cases, from coding to marketing emails, and a lot of those that we want to automate. So for some customers, Brick's going to be where they start, and for other customers, that's really all they're going to be needing to do. All right, so starting with information extraction. When you go to information extraction, this is your structured JSON formatting. Pretty straightforward task that has been difficult to do for a long time. But getting that format right is going to be key. So for our first task, let's say we work with our HR a lot, and they're saying, we have a lot of job descriptions, we've given a lot of offer letters, and we're doing manual data entry. Every time we give an offer letter, like, we want to capture what that role was, what the salary was, like everything we put into that offer. So I'm going to go into my Client Care, look at all my offer letters, so into my Client Care catalog, into my HR schema. And I'm going to just pull up Client Care offer letters and select the full offer letter text. And what we want to be able to do here is automate processes from manual data entry. If you saw the session, it was Archika's session, she showed information extraction. She also showed using PDFs directly and using a parser beforehand. So that's kind of like essentially a multi-agent step, where maybe you have raw text files, maybe you just have the PDFs, and you're able to take that and then do the export. I like showing just how fast this JSON extraction is. There's nothing I had to do to that. That's just the sample, and then I can create the agent. It takes about 1 to 3 minutes to just create that, so I've already created the information extraction agent. So I'm going to go back to configure. So I have my offer letters. And then in the build, this is what happens once you click create agent. Once that structure looks pretty good. And there's a lot going on here, but there's 3 main things that get produced. It's not just the one click, here's the JSON extraction. There are 3 agent-based things that are happening on this page. LLM's in the background trying to get the most out of the data you gave it. So the first is just this output result. So this is my offer letter. I have the date, the candidate name, salary, location, NDA terms, 401k information, etc. And then this is my model output. I can change around these entities, but that first step was we took unstructured data and turned it into a structured format. The other things you're able to see going on in this page is after you get these reviews, but you also get recommendations like, hey, this isn't in USD. Is it supposed to be in USD? Might be something to consider when we're producing these job descriptions or these offer letters for you. Maybe specify the candidate's name in a certain format. Is this first name, last name? Is this last name, first name? And so this is from agents in the back end looking at your data and seeing what can I learn from this, how can I help you out? And that's really the difference between, oh, one click, zero shot, here you go, here's the information. Because we've been seeing that a lot, and this week, especially on our calls with analysts, like they want to know, is this right? Like, yes, it worked, it clicked, it loaded, but how do I know that this is secure? How do I know the data is even real? Like, could this secretly be hard-coded, Being able to see that the information you're seeing is real, it's accurate, and it's secure. So the third thing that you'll see here are these details from the entities being extracted. You could think of like column names and descriptions. So okay, so we extracted a start date. We think the start date should be like month, day, year. You can also include any of these recommendations, add them directly into this schema. So like add a new field, benefits eligibility should have this, NDA terms should have this. And if you notice, this is the start of an evaluation metric. So this is an eval. Now you can go through and see, okay, this is start date, it should be in this format. That's kind of a yes or no to make sure my JSON's formatting correctly. And as soon as you update the agent, you get the full review of everything that's going on behind the scenes. But what's even nicer is, okay, so we build an agent, it's doing JSON extraction, that's fine. What if we optimize it? What if we want to do a full optimization, get it working faster, and get it working faster, cheaper, higher throughput? And that's what this optimization does. If you're more interested, like kind of in the R&D research side, a lot of the talks around like TAO or optimization techniques focus on what's going on in the back end here when we click optimize. It takes about 30 minutes to optimize the model. But once you do, then in the review tab, you can see the difference between your optimized model and just the active model, the one that was created with that initial feedback. And I'll get to these graphs in a second, but you can see like the full requests. Don't worry if this looks like a lot. In the second part of the demo, we're gonna go in really detailed to evals, and so the second part is going to break this down a lot more. But you have your inputs, your outputs, your assessments, and basically all those evals that were created, you can see how they're doing. Now, some are doing better than others. Overall, you have a 94% aggregate average for your accuracy, which is pretty good. The point of this demo isn't to show, okay, well now we can go back in and start changing the evaluation, start improving the model. What's really cool is looking at the comparison of these models and saying, oh, okay, the optimized model, same performance, cheaper than the active model, and much higher throughput. And if you see graphs in Databricks that you think might be a little confusing, you can always just take a screenshot, go to Playground. I know I have a lot of screenshots. And say, like, what is this Databricks graph showing? Yeah. Outside the beta stage, it may have a x-axis. And then it's like, okay, this is a Databricks graph. We know Databricks units per hour. We know what the left panel is showing, and we know what the right panel is showing. pretty much what we see is both models have almost an accuracy of 1. I did use this to just make sure I was doing the demo correctly. I'm like, you guys might want to see this because this is kind of what we're doing behind the scenes. But the optimized model appears to have a much higher throughput. It's about like 20K. Cost comparison, showing the cost comparison again. Lack of x-axis makes it harder to determine exactly how much, but it is obviously much lower on the graph. All right, so that is for our information extraction. We can also go directly and run information extraction. Let me just go back here real quick. And use it and start running it in batch. So if we start batch extraction, I'm not sure how this will perform with the Wi-Fi. There's also kind of a few other ones going on here. I have it. Yeah. So if you run this in batch, and we have a lot of optimizations currently in our latest batch processing, you can see exactly what these outputs look like. All right. Now let's look at our next agent. So just to recap, we did the JSON extraction. We were able to pull key information from offer letters. And now for client care, let's say that our recruiters want to use the information from those offer letters. They want to use information from previous job descriptions, and they want to actually generate new job descriptions. So this is more of a custom generation task. And for that, we're going to use custom LLM. With custom LLM, you describe your task. You can use labeled data, unlabeled data, or even input a few individual in and out samples. Add the destination of where you want this agent to live, where you want this deployed agent to stay. Create the agent, and then where you register this in Unity Catalog, all the feedback from that agent will also exist there. Again, it takes a few minutes to run, but I've already built one out for custom LLM. So this is our job description agent. And actually, why don't I just show you what a job description I made looks like so you can see the difference between what was just created. So going into Unity Catalog, into my client care schema, I'm going to go into my HR file here and pull up my job descriptions, look at the sample data. So this is the job description I've created. Customer experience manager, it has a salary range, it has the location, job summary, responsibilities. So kind of a standard JD. So when we want the agent to create job descriptions, going back into custom LLM, we already selected the data. I just showed you the data, bunch of job descriptions, and you can add in those key entity extractions if you say, hey, like maybe update the ranges if they don't fall within this task. It's more of a multi-agent capability. But again, your page that's coming afterwards has all these things generated for you. So you have these review samples, which were directly created from the data that that agent saw, any descriptions that you use. We're just using very, very minimal descriptions here just to show you that, what Craig was talking about, that zero-shot offering. Here we can see business analyst, database administrator. What's funny is a lot of these titles aren't even in my initial job description data set. And so if I wanted to add guidelines like I'm only hiring for engineering, it could start just creating engineering job descriptions. But what's really cool here is, so it created that, and now we still have these guidelines. Let's see what one of these guidelines says. Like the job description must include salary range consistent with standard. Yes, I like that. Qualification should be realistic. It's not always the case, but I think that should go in. Primary responsibilities, job title, and then you can also start reviewing and add feedback to what is initially being generated, so these agent tasks. And as I update this agent, then I'm gonna just leave here. You'll see those turned automatically into evals. So these are just first pass evals that were first generated based on the job description the agent built. So let's look at technical writer. So technical writer was generated. I selected a bunch of the suggestions. I'm like, yes, that's true, that's true, that's true, all just based on initial data I handed it. And a lot of people starting to work with agents say like, okay, like, you know, there's 3 types of evals. There's code-based evals, so hard-coded yes or no, like, you know, there's no deviation. There's LLM as a judge, and then there's human-in-the-loop feedback. What's interesting about these evals is that it's kind of combining LLM as a judge and human-in-the-loop feedback, because it's saying, you know, before we just automate this, like, why don't you give us feedback to it? And that's an initial evaluation. All right, and so yeah, these you can continue to iterate on. Say like, okay, like I saw what those look like, want to add in some more guidelines, just continue that iterative process, and then you can still optimize and try on your own data. Okay, to recap those 2 bricks, so we just did information extraction, where we pulled JSON formats from unstructured data. Then we did custom LLM, so a custom generation task, where we gave custom LLM a bunch of job descriptions, and we said, okay, create new job descriptions based on this task, or create new job descriptions based on the data that I'm providing you. It did it pretty well, gave us feedback of like, hey, like, should this be here? Like, is this important? Yes, yes, yes. Turn those into evaluations as a first round pass of making sure that you like what you're seeing. Lastly is the knowledge assistant, so turning your docs into a chatbot. I think this is really good if you need, you need the exact document that said like, oh, this happened. This is where you got that information from. And so if I click on knowledge assistant, we've already done a lot for recruiters. We've built, information extraction and did that information on offer letters. Then we built a custom LLM to help them generate job descriptions. But anytime you actually get to the end of the interview process with a candidate, they're normally expecting negotiations and then an offer. And we know that stage can take a while. Like, is there something we can build that would give direct information to the recruiter of if they can offer this, if they can offer that, where they don't have to constantly escalate information, and where they can keep it all together, because as we know, like different roles, they have different liberties with each of that. I should actually talk to a recruiter to see if this is something they would like, but just going off of kind of key capabilities that you get, everything the recruiter offers pretty much has to come directly from the mouth of someone else. So if they have in writing and they could pull those specific documents each time they have a question, then all the bases should be covered, and it should really help candidates. So I'm going to go through actually what I built and what those inputs look like. So starting with your configuration, you can name your chatbot. So this is candidate bot. The description is once job candidates pass their last round of interviews, they expect an offer or negotiations afterwards. You will help HR reps and recruiters answer questions during those negotiations. Hopefully this decreases the time it takes to get a candidate to accept an offer. I'm going to pull the information from my HR schema. I'm going to pull in, I know it says confirmation policies, but I promise you this is all the compensation policies. We know natural language is hard. The description for what you're getting here, okay, this is a document of all the client care company policies, can answer the questions and give them information on their compensation. Knowledge sources, so it handles volumes, vector databases. This is my vector database for all my job descriptions, which a lot of recruiters also need in the negotiations. And then instructions. If the answer doesn't exist, don't make anything up. Just go to the hiring manager if you need extra support there. Anytime you update an agent, so add in more data, you'll see it on the side here. You can sync those data resources. So anytime you update a vector database, You can sync that information or have it done for you automatically. What's great about our vector database is it automatically synchronizes and permissions within the Databricks vector database is also sync. All right, this runs an experiment in MLflow. If you saw, we created the MLflow 3.0 API, announced it this week. It is available in platform for everyone, and you'll see a lot more of that in the next set of demos. All right, but overall, you set up this information, and then you can click into improve quality. You can add in specific questions. So this is where that human-in-the-loop feedback really comes in. And you can either start in Playground, or you can start by opening label sessions. So if I open a labeling session, all right, looks like I have one open here. All right, so this is what, as soon as you open a labeling session, you can see the inputs and outputs for those specific questions that you want feedback on. So can a recruiter approve a 10K signing bonus? The agent looks at that information, says, yes, they can. It falls within this information. Is there anything else I need to think about? No, I think that's good. It's correct. I could say thumbs up, thumbs down. I can add additional information. I could say, if they're asking for over 10 and they're this level, or their base is, X, I could add in any of this feedback if I am a recruiter, and the agent will take that into account once you update it. So kind of just going through these responses. What is the state and PTO for new employees? Well, the standard PTO is 15 vacation days, 10 company days, 5 sick days. Note, we'll be transitioning to unlimited PTO in July. Oh, that's interesting because, initially we were going to say we're transitioning in July, but it actually is probably more likely going to be August. So I'm actually going to say add input. If I wanted particular guidelines, recheck with the latest info from company policies, save that, leave feedback. Because overall, yes, this is correct, but don't mention PTO yet. All that information gets saved, put back into the system. You can continue to do your reviews. Once those reviews are done, you can merge them back. So I already have one recorded review session. You merge those back, and then your agent's updated with that information. You can also just try out this endpoint directly in Playground, and each time you update that agent, you can see in the responses the information it provides back and where it got that information. So say there is someone asking about a 10K signing bonus. I'm the recruiter. Can I approve a 10K signing bonus? This endpoint should be awake. When you do create an endpoint, it pretty much refreshes or stays active fully for 20 minutes. Then it has to wake up. It's normally just a minute or two, but a minute or two feels like a lifetime when you're just waiting up here. All right, so we see, yes, you can approve a 10K signing bonus, which is 5 to 10,000. These are the direct sources that I referenced in order to get that information. I have, straightforward AI as a judge evals available, but these evals, really when people ask how complex do I need to make my evals, you can make them as complex as you want. They could be a very straightforward, yes or no, this follows a general format, to very specific information on retrieval, re-ranking, at the trace level, individual steps within an agent. You can keep track of all that, and especially if you're building a multi-agent system, it's not final or initial input, final output. You're looking at every incremental step there. All right, so that covers our 3 AI bricks. So we extracted information from unstructured data pulled those entities from offer letters, we built custom job descriptions, and then we created a RAG chatbot to help with negotiation processes, pulling on direct compensation information and job descriptions that recruiters are using. All right, Craig, back to you.
Thanks, Amber. It's always exciting when you know the demo's live, and it doesn't. The fact that you know it was live was not because it went sideways. So let's dive a little more deeply into the Mosaic AI platform and some of the capabilities in that platform. This is the platform as we showed it, I think, most of last year, and basically this idea that to be successful with AI and GenAI, it's about preparing the data, building the agents, deploying the agents, evaluating the agents, and then ultimately governing all of those pieces, really having the utmost control and monitoring over exactly what these agents are doing and exactly what they have access to. So let's start with preparing the data. The big surprise for us in the data space, we knew that the vector search was going to be critical. We built it as soon as this whole kind of craze started. What we were unprepared for was how excited people would be to serve ML features into these systems as well, right? How important it was, you're building that customer service chatbot. It's important to know what's the last thing this customer bought from us, or when's the last time they contacted us, and what was that contact about? That's all structured data for folks, right? And so having the ability to seamlessly bring in structured and unstructured data in a fully governed manner, we see as one of those critical capabilities to being successful with this technology. Now, on the vector search side, there have been some pain points, which is that folks haven't been really used to what it takes to kind of stand up a vector search capability. And one of the specific pain points that we heard again and again and again was related to the cost of these systems. And we'll talk about that in a second. But really on this data side, the first thing I wanted to share with you is our new document intelligence SQL capability. This is AI_parse that you can use directly in SQL, as you see here, and you can use it to parse documents. Now you might ask, hey Craig, what's the difference between this and information extraction? You should think about information extraction as that system that you've tuned to be really high performant. This is more of your zero shot. Hey, you have a set of documents that are pretty simple to do this with. Maybe you don't have that many of them. You're willing to check and make sure some of the responses are strong, but you don't want to have to hand enter everything. Whereas you might want to use bricks and build your own system if you know you're going to have thousands of these documents, and you're going to continue to have thousands of these documents coming in, and you really want to ensure that this is a production system that you can use again and again and again. Now, we also have built out a series of AI functions directly in SQL, really trying to bring AI to our SQL users or our non-kind of AI builders. These include AI query. AI query lets you query any model. That might be an agent you've built. That might be an LLM. That might be a classical machine learning model. You can then score that whatever table you want or whatever data you want with basically telling us the model, giving us the input, the prompt you want scored, and then we'll score it over the entire batch or the entire table. Forecast, pretty clear. Summarize, pretty clear. And then translate. A translate API so you can change languages. I will say this translate API, we're using an LLM, right? This isn't like the Google Translate or the most high performant translate in the world. But again, maybe you have a small, you've got something in another language, you want to kind of understand it. Whereas if you're putting together a publication that you're going to publish out to the world, maybe use something a little more potent and a little more powerful than the SQL function there. Rivian, right? Rivian uses these AI functions to go and allow their SQL analysts to go and understand how are vehicles performing for safety by using some of these models they've built to be able to deploy in massive batch instances just with the simplicity of SQL. First American, they use some of our AI query capabilities against a fine-tuned LLM to do basically information extraction to be able to understand the thousands and thousands or hundreds of thousands of titles they have going back more than 100 years, right? So And then finally, I mentioned the cost of vector search, right? And the challenge for some folks of vector search. The challenge is, just to be clear, if you haven't run into it, is that if you increase the size of your embeddings, right? If you get more and more embeddings, traditionally, you actually, in vector search instances, have to increase the compute linearly with the amount of embeddings you have. And that's fine if you're running a relatively small embedding field and you're hitting it frequently. But if you have massive number of embeddings and you're not hitting them all that frequently, it can be extraordinarily costly. So what we've done here is we've given you other shapes so that you can have a storage optimized where we can handle a much larger embedding field at a much lower cost. Now, if we move from data into the building of the agents, right, into the meat of it, if you will, first of all, we are massively model agnostic. I shouldn't say we're model agnostic. We are very opinionated about models, and we think you should use the model that performs best for your use case, right? Not just the model that we have available or something like that. We have models that we host on your behalf, so open source models or Claude. And then we have models that you can bring in as API endpoints. Let's say you want to use OpenAI or Grok or something like that. You can bring that endpoint in. We'll govern, monitor, policy it just like we would if it was a model that you had built yourself. Now, really excited today to announce that Gemini is now going to be natively available on Databricks. So you'll have both Claude and Gemini regardless of what cloud you're on. So if you're on AWS or Azure and want to take advantage of Gemini, you now have that capability, despite the fact that it doesn't exist on those clouds today. You have that capability natively inside Databricks. Now, one of the biggest challenges with GenAI is the fact that folks mostly want to build deterministic systems, right? Systems that, hey, when I ask it question A, I get response B, and I get response B every time, right? This idea of deterministic systems is great, except you're using the most probabilistic part of your entire software stack to build this deterministic system, right? And tools have really been a massive differentiator in helping drive this level of determinism forward. They've probably been the single greatest thing we've seen to help customers drive those consistent results time and again. And so this idea of being able to build tools, by the way, a tool, any function, right? So anything you can describe as an input with an output, we can basically stand up as a tool that your model can choose when it should use those tools. Now, this is how, I will just say, the vast majority of significant AI systems we see getting built today are using tool calling as a critical step in driving the determinism of their systems. So with tools, not only, by the way, do we make it easy to build tools on Databricks and easy to govern and monitor those tools on Databricks, but we're happy to announce that MCP will now be a part of that. So MCP, you will now have the ability, or we're announcing the ability, not now, but very shortly, for you to govern and manage MCP servers directly in Unity Catalog, MCP servers that will have access to Unity Catalog's tool registry and access to some of the data that's in Unity Catalog that you might want to make available to your agents. You can now do that using the MCP servers and the MCP protocol. Really excited about what MCP is doing in the industry and the kind of momentum behind it, and really excited to support it in the Unity Catalog as more and more folks want to use it in their high-performance AI systems. And then lastly, serverless GPU compute. It's a heck of an exciting name if you ask me. But serverless GPU compute really is designed to fill a gap, which is that when you want to go and build maybe small large language models, or you want to continuously pre-train or fine-tune a model, you might need not just access to a GPU, you might need an access to a fleet of GPUs, right? And what serverless GPU compute is designed to do is just instantly, well, not instantly, quickly give you access to a fleet of GPUs of whatever size you need. So let's say you want to go fine-tune that 1 billion or maybe even that 40 billion or 70 billion parameter model. We can make it super easy for you by using serverless GPU compute to do it. Now, when we move from building those agents to deploying those agents, really excited with MLflow 3.0. Right? MLflow is designed to help you package up your classical machine learning kind of models. And with 3.0, we're really moving ML flow into being a critical step in the agentic field as well, right? With concepts like tracing, concepts like evaluation, versioning, and gateway. With ML flow, of all of these, I'll just touch on tracing real quick. Tracing is really at the heart of our evaluation system. And what tracing does is instead of our evaluation looking at the input to your prompt and the output of the response, instead of just looking at those two and trying to understand whether or not that was a high quality response, what tracing does is it gives us access to look at the input of every single step of that agent. So now instead of diagnosing whether this was a good response or not, we can actually look and see like, hey, step 3, did we get retrieval? Did we nail the retrieval on step 3, or is that what's causing the problem here? It really moves debugging and improving the quality from being a kind of, well, I'll bang it with a hammer and see if it works better, into a much more surgical precision activity where we can go and kind of, target really where we saw the entropy kind of explode or where we saw the hallucinations start to begin, so that we can really drive accuracy of these systems moving forward. We're excited about this becoming a greater and greater standard in the market. We're seeing more and more of the clouds pick up tracing, and really hoping that that becomes kind of the de facto way for folks to understand the kind of how their systems are working and the performance of those systems. Now we move to evaluation. Right? This is our evaluation stack. You'll see it more in the demo shortly. As I just mentioned with tracing, the idea here is, you can see the page. What we do is we take your golden data set and we run it through and we look for very specific failure patterns. We have a series of pre-created judges. You can also create your own judge. And we score those judges trying to figure out, hey, when there was a problem, where was the problem? If we were to click on one of these little red circles, a page would actually come up that would show you the input and the output at what step we think failed, what was the input of that step, what was the output of that step, why do we think that step failed, and what do we think you should go do to go fix that. That's really what's differentiating building on Databricks, and the ability, instead of having kind of these manual vibe checks, to really get surgical about how we improve these systems. I was recently talking to a customer who said, hey, they now have a policy in their company that any system that goes beyond kind of your immediate team's usage, any system that you're going to move to production, if you will, has to have evaluations that meet a certain exit criteria before they're allowed to move them to that stage in the life cycle. And then that whole eval system can also be run as an ongoing monitor. So once you move it into that beta or into that prod stack, you can now run those judges and run that evaluation on your production traffic so that you can see, am I getting the kinds of results in production that I was expecting when I ran this myself, right? This is really at the heart of helping ensure that these systems are doing what we want to. You can then very easily take these prompts, bring them back, push them into the eval system, review them, have your subject matter expert review them, and really drive continued improvements in your accuracy moving forward. And then lastly, governing. When I think about what's necessary for being successful in GenAI, I actually think it's just 2 things. It's control, which is governance and monitoring, and it's accuracy, which is evaluation. And so having the ability to control this system, and not just, hey, who has access to my agent, but let's govern this agent as a principle itself, right? Let's be very declarative about exactly what data sources it can hit, exactly what models it can use, exactly what functions or tools it can call, right? So that we know exactly what it can do. Time and again when I meet with, C-suite folks and stuff like this, they're often terrified of this technology. Right, because they're terrified that it's going to go and take all their data and go and hit APIs that are super important and they don't want hit and all these kinds of things. With this deep level of governance, Unity Catalog gives you the ability not just to govern your data and not just to govern your models, but to govern the tools, to govern the MCP servers, to govern the embeddings, to govern all of the components that are necessary to build high quality AI systems. So that is the stack. We're beyond excited about some of these new pieces of it that we've launched, and really excited about the continued investment we see from organizations into governing and evaluating their Gen AI using Unity Catalog and using our evaluation suite. With that, we'll have Amber come back up and kind of give you an end-to-end view of that entire experience.
Back by popular demand. All right. All right, thank you, Craig, for diving into the Mosaic capabilities. That last slide you saw of build the data, or I guess prepare the data, build the model, do the evaluations. That's, if you go to any of the agent kind of San Francisco conferences lately, you'll see that a lot. They're just missing the governance bubble a lot of times at the end. And really, I feel like Databricks just sits between the startup world of agents and building and the hyperscalers. So your AWS, your Google, it has all the latest capabilities being built in, but that governance angle is, I've been talking to a lot of developers on the agent ops side who thought, oh, I thought observability was enough. I'm here to show you the full governance aspect and why observability is great. It used to just be all we had, were traces and observability. Now, with evaluations, we're adding in a lot of layers of governance. So to kick this off, we're still going back to client care. We love working at client care. And if I want to build, say I don't want to use bricks, I want to build a full agent. I want control of the LLM. I want all the details. You're going to get all the details end to end right now. I'm going to select my Claude 3.7 Sonnet model, which available natively in Databricks. Have a lot more coming natively in Databricks, all the Gemini models, but all the Claude and Llama models are already available. If you see this image right here, it means it's a tool call. It's enabled for tool calling, which most of our LLMs are enabled for tool calling. So I've already created these functions, created them using data I stored in Unity Catalog. I use SQL queries. I mostly use Python and wrapped it kind of in the SQL editor, and created my hosted function. So this is a function that's going to get me all my customer history, going to get me all my product info, and then I have a vector database that has all my company policies. And I'm going to essentially give Claude access to all these capabilities, and that's my agent. For my system prompt, again, we're keeping everything very straightforward. You are a customer support chatbot for a company called Client Care. And if I'm a customer, I'm probably going to want to talk to customer service for returns, exchanges. So I'm going to say, can you help me return my order? And then probably providing an email or an ID. My customer ID is 1234. We're hoping it's more secure than that, but what Claude is going to do is pull up customer history and then go from there, pretty much looking at what a normal customer service agent should do. You're on the phone with someone, you want to pull up all their information, see what things they recently purchased, and then see if you're able to make those returns. And what's interesting is depending, again, on the LLM, or maybe the kind of day that LLM is having, you might get different responses. So here we can see that Claude pulled up my customer history. It said, okay, here are the items you've purchased. You purchased a toaster, you already returned that item, and then you have purchased headphones. You got them June 1st, and they have not been returned. So these are your items. Which item would you like to return? By the way, only one is eligible for a return. And so you can provide feedback. This is a great chance, provide feedback, say, don't even show me the ones that are already returned. Certain models, Claude 4 actually won't show that, and it takes the liberty of going right to the company policies and does it all in one go. It looks at every tool it has access to and then goes through each one. But if you want more of a human experience, you're going to have to test it out. And this is normally how a real customer support agent works. 3.7 is also a little bit cheaper, a little bit faster, so all these things go into consideration when building your agent. So I'm going to say yes, like help me return the headphones. And remember, I gave it access to a lot of product info as well as the return policies. Right now, I'm only putting, yes, the headphones. So naturally, Claude's going to go and first look into products. Like, oh, it said headphones. I'm not actually seeing anything here that helps me with this response. So I'm actually going to go into my policies and then pull up the relevant information. So here it's pulling up the relevant information from policies. Okay, this is within the 30-day return window. Do you have the original packaging? This is our full process. These are all the documents that were used for this. The key example I like to show when building an agent is these are the things that are kind of going through your head, like, oh, like it took this path. Now things like the path it took, the path length are all evals when building an agent. You want to make sure it's taking the same path every time, it's querying the same tools, it's querying them in the same order you would expect. And so these are just new things to start considering when building an agent. All right, so I think that looks pretty good. I can now get this directly ported to a notebook. And now we have a tool calling notebook. So this is auto-generated, uses Mosaic AI framework, and it created a full agent just based on what you had in Playground. It uses LangChain, but you can use any agent authoring framework. And now we're going to go in very deep detail into each cell of this notebook. No, I'm just kidding. But if you are interested in doing that, we do have a GenAI workshop where we go through and see how to edit this more from a dev perspective. Either way, what you're going to be doing, like even within this notebook, is setting up your evaluations. So you can set up custom evaluations. You can use our in-house LLM as a judge. If you have a RAG chatbot, it automatically looks at your retrieval metrics, your response metrics, looks at correctness. We have a whole set of evals there. Again, you can put in custom ones, and you just really need to define what LLM you want to do the judging, and then a bit of prompting to make sure the description is met. I already went through some of the evaluations, which I can find in my experiment tab. Where are we? All right, my experiments. I had them already loaded. It's fine, they don't take very long to load. So I go into my driver notebook, which that was what was created initially. Go into my evaluations, and I can look at individual runs. So let me just pull this up real quick so I could show you in more detail what I'm getting from the traces. So now we're seeing a version 1, or V0 actually, of the chatbot. So I added in evaluations. I actually just went with 2 default ones. I took out the other evaluations. If you've seen an agent with real evaluations done in aggregate, you know it can get a little messy, so we're just going to focus on correctness right now. So we're seeing good responses for our agent, like did my payment for the EcoDry clothes dryer go through? You know, what's being pulled? Okay, I'm going to pull customer history. I'm going to generate a final response. Like I can confirm that your payment went through. According to our records, you purchased it in August 17th, 2024, it has not been returned, yada, yada. So that's an example of, okay, that was successful. You can also add in expected facts. These are like your ground truths. So you can add in ground truths. They could be when you initially run evals, or you could do review app, which that's going to be the next thing I show you. But you can continue to add in any information into your evals to make sure they're as performant as possible. Now let's see, is there a recall for the Blendmaster 3000? All right, so I'm looking at my agent, I'm looking what's happening under the hood. I see we looked up product info for the Blendmaster 3000. I don't see any information here about it, and assistant actually says, I don't see any information about that product. It could be a typo. Could you give me more information? Trying to see what the Blend Master 3000 is. So it wasn't able to answer this question. If you saw the initial, and I know you saw it because you were all here, the initial tools that I gave the agent, I didn't give it access specifically to anything about recalled items. So I reran this agent with one extra tool that gives it access to all recently recalled items, and that is in my V1 run. Actually, I'm gonna just zoom in on this first. Okay, so now if I look, is there a recall for the Blend Master 3000? I see that eval passes, and I can do direct comparisons to other runs. So we see the increase in performance. Again, you can add in as many evals as you'd like. I believe we're calling them scores now in MLflow 3.0, and these still essentially are your judges. Remember we talked about the 3 types of evals. You have your essentially hard-coded evals that are yes or no, can't be deterministic, and then you have your LLM judges, and then you have your human in the loop. So first, just to see exactly like what happened to the Blend Master 3000 now, we know what happened before. You know, it was a fail. It wasn't able to pull up the right information. But now we're seeing correct and safe. And we can see the response was, the expectation states that there was a recall on March 10th. Response confirms that there was a recall on March 10th. So it's giving the correct information back. We can look at the final, or we can look at the initial input request. And if we want to kind of stop this comparison, then you get just the trace view of that individual one. Again, this is a new API, so if you were used to MLflow before 3, there are going to be a few changes to it, but overall it's a pretty sleek UI, and it's now like optimized for putting in a lot of different evals. And so yes, I can confirm there is a recall for the Blend Master 3000, blah, blah, blah. All right, so that's really how you go about resolving problems with your agents. You see like, okay, where are these errors in these evals that I specified? And honestly, I say start with the out-of-the-box evals, because if those ones aren't hitting, like your specialized evals aren't gonna really help you until you start getting that first round. All right, so we talked about the LLM as a judge evaluations. Now let's look at human in the loop evaluations. So in that notebook, these are MLflow runs. It starts that MLflow run for you. It runs your evals. You can edit it as you like. And then because it deploys that endpoint, you can then serve it as an application. So if I go into serving and click my client care endpoint, I can see my active endpoint right here. I can see the versions of my model, and we'll get into this in a second, but we have our own AI gateway, and so we can start logging all the inferences through it, and they all get stored in Unity Catalog. So any responses from your LLM, those get stored, and you have that information. But I can use this, I can either go back to Playground, continue to iterate on this agent, or I can open it in our review app. So this is what the review app looks like. If I had specific tasks that I was assigned, I'd be able to see those. That's what you initially saw in Knowledge Assistant when those tasks were assigned to you. All right, so again, let's just say, I'm looking to return my order. An item. And so this is the exact same question that I asked that agent initially. So you can have a set of key questions you want to send over to someone in your engineering team, any subject matter expert where you really value that feedback, and you don't just want an LLM to label all your critical data of making the final decisions. All right, so we can see that it is pulling up your customer history, pulling up the item, has the 2 key parts of information. Remember I said before, like, oh, maybe you don't want to show anything you've already returned. So I could either say it's a good response and offer feedback, or a bad response and offer my feedback. If you put no, it will flag as like this is incorrect, and those are discussed within your team. Some people are like, how do I know if my eval is good enough? I'm like, well, how do you know like your own response is good enough? That's something very, you know, it's tricky, and like Craig was saying, there's people that want, oh, I want every time I ping my agent to do this, it's going to say that every time. But that's not what a human would do. We're trying to get to that human level accuracy and trying to get the agent to not have unwanted permissions. All right, so no, don't show returned items. Done. That feedback is saved, and that feedback is now saved in Unity catalog. All right. Lastly, I just wanted to share our AI gateway. Monitoring is becoming a very big point for AI agents, but really you can only have good monitoring once you have good evals. Your monitoring is only as good as the evaluations you're running them through. We have evaluations for cost, for rate limits, but for performance, you just have to make sure your evals look good, and then you can put any of those metrics into a table within our dashboard capabilities. When you turn on, and I could actually show this. Yeah, so when you turn on an endpoint, you have the ability to select AI Gateway. Let me show you a brand new endpoint, actually. So here's AI Gateway, so monitoring your endpoints. So you can select enable usage tracking, inference tables. So this is how it actually all gets stored to your Unity catalog. AI guardrails, so all your inputs, outputs, PII detection, safety. Yeah, so inputs and outputs for before and after it pings an LLM. Again, if this is actually a natively deployed LLM within Databricks, you have a lot more security already enabled. So it's going to look different if you select a natively available endpoint. Rate limits and enabling fallback. And so then having all those is what you see when you build. Let's go back. Did I? All right, it shouldn't take too long to reload. The internet, the demo gods have been kind today. All right, so this is, again, everything you log from AI Gateway, but just displayed in our dashboard capabilities. So here are our inference tables. So these are the full payload. You can unpack those payloads. We use inference tables and payload logging interchangeably, pretty much, at Databricks. But you can pull all that information and enable fallback. So say you're using Claude models in different regions. If one model goes down, having a backup one available, because no matter how good your agent is, everything could go down. So making sure you have those capabilities in play. Having key information for usage tracking. So this is kind of the admin privileges behind your endpoints. So cost attribution, abuse detection, you could track this for all endpoints or single endpoints. This one is probably me. I do a lot of demos. The PII audit requests. So this is mostly for your external models. We have custom model support. So any model you want to use, you can use within Databricks and have that be logged. All right, so we are, perfect on time, 10 minutes for question. Thank you everyone so much for joining, and we'll be taking questions.